Good morning, IB Math. We're moving on to 6C, and right now we're going to talk about angles of measures. Now, we're used to doing everything in 360 degrees, but we're going to introduce the idea of radians in a moment, and you should have seen that. Everybody that's been through college algebra should have seen that. Pre-calc students are definitely going to have a great upper hand right here, but we won't really be getting as intense into the unit circle and identities as the pre-calc did. We'll certainly get into some of that. Before I do, I just want to take a look at all of the names we're going to be using. So hopefully this next part here will be mostly review from geometry. I want you to think about a circle. Oh, that one's not too bad. Well, maybe. I don't know. And I want to talk about all the different lines and segments that are associated. Now, a circle is really a two-dimensional construct. It has length and it has width. And we have a center of the circle. And if we name the center, call this point K. Now, a point, remember, has no dimensions, no length, no width, no breadth, no height, no depth, no nothing. Then we can name the circle, and we use the symbol this to represent a circle, and we call it circle K. Okay? Okay. Thank you for those of you that are laughing right now. The lines associated with circle are diameter, and if I call this point A and this point B, then I have diameter, segment AB. Now notice, no arrows, it's not a line, it's a segment AB. Starts at A, goes to B. Diameters must contain the center of the circle. If it doesn't contain the center of the circle, CD. I had segment CD here that does not contain the center of the circle. That's called a chord. Also, any segment that goes from the center to some point on the circle is a radius. These are all segments. Now, other than segments, there are two lines that we need to know. I could have a line that goes through the circle. Let's see, so F and G. This is line FG, and it is a secant line. FG line. It goes through the circle. I could also have chord FG, but this is secant line FG. And then the last one is I can have a line that touches the circle in one and only one place, where the secant line touches it twice. Another line that touches it in one and only one place, and I think we know the name of this one already, is I didn't write secant line here, did I? Secant line, tangent line. Let me give another point on there, call it H. So tangent line is the line EH, and this point right here is the point of tangency, point E, where the tangent line touches the circle. And we have a special theorem about that. A tangent line at a point of tangency is a right angle. It's always a right angle. All right, so these are all the lines that we need to know. All the lines that are associated with a circle. We're going to use all of these words, and there shouldn't be anything new up here. This is all from geometry, even regular geometry. If you didn't have honors, you should still have done all of these lines. All right, so now let's get into actual angle measures as we use some of these words. We're used to doing everything in degrees. And if we think about degrees in a circle, we think about an angle, I'm going to call it theta here, and I would say that this looks like, theta looks like about a 45-degree angle. We've got a little symbol, degrees there. And a full circle is 360 degrees. 360 degrees around. Now, I can get into parts of a circle. 1 degree is equal to 60 minutes. The little dash mark there means minutes. 1 minute equals 60 seconds. So I can have DMS, degrees, minutes, and seconds. I could have an angle that is 37 degrees, 14 minutes, and 52 seconds. That's kind of the decimal version of an angle in degrees. We really don't want to use degrees, though. Where we really want to be is radians. All right, so this might be a lot of new stuff here. Again, I want you to think about a circle. And I want you to think about an angle in a circle. And I'm going to call the angle theta again. But this time, the important things are the radius. I mean, I have a radius here as well, but the radius didn't come into any of the calculations for the degree. It doesn't matter what the radius is. I could have a 45-degree angle on a circle with a radius of 10, or a 45-degree angle on a circle with a radius of 1. It doesn't matter. But here it does, because I've got radians and arc length. S is arc length. Okay, so the radian symbol here is going to give me a relationship between the arc length and the radius. So a full theta is going to be equal to, it's the ratio of arc length over radius. Theta equals S over R. A full circle would have a full circle, and if I think about the arc length here, if the radius was 1, the arc length would be a full circle. How long would that be? Well, circumference equals 2 times pi times r. 2 times pi times 1 is 2 pi. So a full circle is 2 pi radians. We don't have a really clever little symbol like the degree symbol. Sometimes we'll write radians. Your textbook often uses the symbol C for radians. I don't know why. I've not seen that before. I don't know if it's an international symbol. But a lot of times we don't write anything at all there, especially if there's pi's. You can just leave it without writing anything there at all. All right, we need to be able to convert from degrees to radians and radians to degrees. So let's talk about converting. All right, if we're going to convert from degrees to radians, well, I know that there are 360 degrees is 2 pi radians. So if I've got something in degrees, I can take whatever it is in degrees and multiply it by 2 pi radians over 360 degrees. And of course I can simplify my unit conversion here and just say pi radians over 180 degrees. For example, let's say I want to convert let's see, 45 degrees, and I want to convert it to radians. All right, so I'm going to take 45 degrees times pi radians over 180 degrees. Notice the degrees are going to cancel. And then 45 over 180, how many times does 45 go into 180? Let's see, 1, 2, 3, 4, 5, 6, 7, 8 times. So 45 degrees would be, into 180, 1, 2, 3, 4, pi over 4. And then if I want to be formal, just put RAD for radians. All right, what about converting the other way? Radians to degrees. Well, I'm going to use the same unit conversion, but this time I'm going to say 360 degrees is 2 pi radians, and I can simplify this into 180 degrees over pi radians. Let's look at an example. Let's convert pi over 6 radians. Now notice in radians we often leave them like this. 1/4 of pi or pi over 6, we leave it like that. So I'm going to take pi over 6 and multiply it by 180 degrees over pi radians. This is in radians, by the way. So the radians will cancel, so will the pi's. And I get 180 divided by 6, which is 30 degrees. So here's my unit conversions, either pi over 180 if I'm going degrees to radians, or 180 over pi if I'm going from radians to degrees. All right, so the homework that you're going to see is problem number 1, you're going to have a whole bunch of them where you're going to convert from degrees to radians. Part 2, a whole bunch from radians to degrees. Part 3, you're going to convert each angle to radians to 3 sig figs. Part 4, radians to degrees with 3 sig figs. And then looking at an isosceles triangle. Now, do we remember what an isosceles triangle is? For problem number 5, the textbook assumes you remember a lot of this stuff from your geometry class. In an isosceles triangle, I've got 2 congruent sides and 2 congruent angles. The base angles are congruent. This is called the vertex. The 2 sides are congruent, and the 2 base angles are congruent. So think about this when you're doing problem number 5. All right, you are ready. So now I want you to go do homework 6C. It's on page 380, and I want you to do problems 1 through 5. And as I said, problems 1 and 3 are converting from degrees to radians, 2 and 4 from radians to degrees, and 5 is messing around with an isosceles triangle. And remember, when you're sending these to me, try to put it as either one PDF file or one JPEG file and email it to me. If you've got any questions, if you couldn't figure out one of the problems, then put a thing in the posts saying, oh, I didn't understand problem 4J or something. And then if you see something in the post and you got it, then go ahead and answer that. Go ahead and write down, oh, here it is, and upload a picture or explain it. You can even make a brief video if you like and post a video on it. And answer the question. Otherwise, I will answer the questions as well. All right, guys, good luck, and I will talk to you again soon. Bye.